Alright, here I am writing the answer key. I'm going to go fairly fast, so you might have to pause and replay some of this to hear exactly what I'm saying. In any right triangle, if you know two sides, you can find the third by using Pythagoras. If you write a squared plus b squared equals c squared, and remember the c is the hypotenuse, that can help you keep things in the right order. 24 squared plus 32 squared equals c squared. When you do the math and add it all up, turns out that this is the 3, 4, 5 triangle in disguise. This is 3 times 8. This is 4 times 8. This is going to be 5 times 8. When you do the math, it turns out to be 40 is C. Okay? For number 2, same thing. It's two sides of a right triangle, but this time we know the hypotenuse. So if you write a squared plus b squared equals c squared, you'll know that it's 4 squared plus w squared equals 8 squared, and you'll resist the temptation to subtract the wrong way. 16 then plus w squared equals 64. W squared then is equal to 48, and then w is exactly equal to, and here's where I do the factor tree, 2 and 24, and 2 and 12, and 2 and 6, and then 2 and 3, and I get two pairs of 2 that come out. So it's 2 times, and the lonely radical 3. That's 4 radical 3 is the best answer. This is also a 30, 60, 90, because if you happen to reflect this down, you'll see that that's 4, and then this is going to be 8 as well, and it's an equilateral triangle that's been cut in half, and that's our shortcut. It's always radical 3 times 4. So you can do this with a shortcut. The approximate answer is going to be 4 times radical 3. And I'm not going to type that into my calculator now to find, but you can do that. Use the wavy equal sign. It's going to be something like, I don't know, like 6 or 7. All right? So here we are, 3. This is 30 degrees, so this is a SOHCAHTOA problem. Or, if you realize again that it's a shortcut triangle, it's one of our special triangles because it's a 30, 60, 90 triangle. We can just double 5 to get to x. That's 10 because that's the hypotenuse. Again, if you think about the other half of this that's missing, this is going to be 5, and this is going to be 60 degrees here because that's 30 degrees, and 5 plus 5 makes 10. Then this is going to be exactly 5 times radical 3. All right, and you can say what the decimal is again by typing in your calculator and multiplying by radical 3. You could also do SOHCAHTOA, in which case this is the opposite side, and we're looking for the hypotenuse or the y, so you're going to do sine of 30 degrees for the to find the hypotenuse, and that's going to be equal to 5 over x, and then we would find that decimal and then cross multiply and solve, and you're going to get the decimal version, but you would not get the exact version. Okay? To solve for y, you're going to use the tangent because 5 and y are the opposite and adjacent. For number 4, we've got strictly SOHCAHTOA. The only way to solve this, to find an angle, can't use Pythagoras because it doesn't help us. If we were asked that, we could find it, but to find the angle, we have to say, well, this is the opposite side, and I don't care what that is. This is the hypotenuse, and this is then the adjacent side. So the only trig ratio, SOHCAHTOA, that uses A and H is CA. So CA tells me it's the cosine of W, which I do not know, but it's equal to 7 over 16. So now I have to go to my calculator, and I have to say, alright, so undoing the cosine is the inverse cosine. That's always going to tell me an angle. The cosine to the -1 of 7 divided by 16, because I know that that's the ratio I'm going to get when I have that angle and I look for the cosine. So it's 64.05 degrees. So W is approximately equal to 64 degrees. All right? So that's that page. The next page is going to be, how long is the diagonal of a square with 10 centimeter sides? So if I've got 10 on a side and it's a square, again, this is a right triangle problem, shortcut answer is it's always going to be 10 times my magic multiplier radical 2. 10 radical 2, which is approximately equal to 14.14. If I do the Pythagoras, I will get 10 squared plus 10 squared square rooted, and that's a square root of 200, which is 14.14. Find the area of the following triangle. Well, to find the area, I need 1/2 base times the height. I've got the height there is 3, but I need the base right there. And so I've got to do Pythagoras. I do 25, which is 5 squared. That's going to be equal to 3 squared plus b for base squared. And that's going to be 9 plus b squared. So 16 is equal to b squared. Well, that's just 4. This is the famous 3, 4, 5 right triangle. So the area then is 1/2 3 times 4, which is 12. And so 1/2 of 12 is 6. That's your area. Show your work and everything will go well. Alright, so I'm doing a similar triangle problem. It doesn't matter how I set up these ratios as long as I am consistent. So 4 over 10 is going to be equal to 2 over x. I cross multiply and get 4x equals 20. So x equals 5. Alright? Then last one is if a square fits perfectly around, circle fits perfectly around the square, find the area of the circle. So that's the area of this whole circle if one side of the square is 8. Well, if the side of the square is 8, then that diagonal, that's also the diameter is equal to 8 times radical 2. Again, you could do the long version, find Pythagoras, and get a decimal, but this is the exact answer. The radius, r, is equal to 4 times radical 2, and the area of the circle is pi r squared. So it's wonderful if you saw that it's just pi times 4 radical 2 squared. No need for a calculator. All you have to do is square 4 to get 16, square radical 2 to get 2. 16 times 2 is 32, so the area is equal to 32 pi, which is approximately 100. Just multiply by 3.14. Thanks a lot.